Okay, so we yesterday introduced something called constant proportionality. This is the same thing as unit rate. More specifically, yesterday we talked about unit rate on a table or constant proportionality. And then today we're talking about constant proportionality on a graph. Same idea though. Constant proportionality is when I have a constant rate of change, and how we find that is we always put y over x, our y value over our x value. Now when it comes to help us with our graphs here, more specifically, I have to be able to take a coordinate. So again, if I'm looking for constant proportionality, we want the y over the x. If I look specifically at number 10, I can choose any dot, just like yesterday when we were talking about tables. I can really do any part of the table itself. So here, I can choose any dot. Let's say I choose this dot right here, the lowest one. You have to be able to decide which number is your y and which one is your x. So you have to know from your graph, this is your x-axis and this is your y-axis. So if I look at this first dot, what is the y? Well, the y lines up with 40 over my x, which is 2. So, and then if I did this dot, it would be 80 over 4. This dot would be 120 over 6. This dot would be 160 over 8. And what you do with each of those is I divide them out. And it does not matter if I do 40 divided by 2, 80 divided by 4, or 120 divided by 6, I should get the same answers. For instance, 40 divided by 2 is 20, 80 divided by 4 is also 20, 120 divided by 6 is also 20, and so on. So K, my constant of variation, is 20, and my equation, like yesterday, is y equals 20x. Not too bad. Let's do that again. Number 11. First things first, this axis is my x and this axis is my y. So when I choose a dot, let's say I choose this dot right here, the closest one, I want my y, which is this line, but between 1 and 2, it would be 1.5, and then my x would be 1. If I choose this dot, it would be 3 over 2. This dot would be 4.5 over 3. This dot would be 6 over 4. So again, it doesn't matter if I do this one over this one, this one over this one. All I have to do is divide it out. So if I choose 1.5 divided by 1, I just get 1.5. If I get 3 divided by 2, 2 goes into 3 once, which has a remainder of 1. I put a decimal and a 0. 2 goes into 10 5 times. So I get 1.5 again. So my constant of variation is 1.5, and my equation would be 1.5x. Not too bad. Now, this one, if you notice off the bat, that what makes it also different is to have a constant of proportionality, it would also have to go through the origin. The origin in this case would be this bottom left corner. If you notice, number 12 does not go through the origin. So let's see what happens because of that. If I look at this first dot here, it says it's this 50 between 50 and 100 is 75 over 2. This one would be 100 over 4. This one is 125 over 6, and this one is 150 over 8. So when I divide them out, 75 divided by 2 is 37.5. 100 divided by 4 is 25. 125 divided by 6 sorry, did that wrong. 20. Point. So it comes out to like a decimal repeating, but it would be 20.8. And you notice it doesn't have the same constant. So that means it doesn't have a constant proportionality, which means this would be no, like we saw in yesterday's. And then if I continue on, I have some situations where I have to find my own coordinates. So if you notice, there's no dots given. I have to find my own. So the first most obvious is the origin. If I scan my line, I look at the corners of every and see how it misses that corner, misses until I get to this one, and I can put a dot there. And then this one, if I continue, scan, I put another dot there. So, oops, sorry, I know that wasn't clear. And so now I can use this dot specifically, which means it's my y over x. If the y is 60 over my x, which is 40, or if I choose this dot, it would be 120 over 8. If I divide both of them out, so 4 goes into 6 once, and then I bring the 0 down, 4 goes into 25 times. So it would be 15 for the first one. If I did 120 over 8, 8 does not go into 1, but 8 goes into 12 once, which is 4. Bring down my 0, 8 goes into 45 times. So this one also gives me 15. So on this question, k equals 15, where my equation would be y equals 15x, just like yesterday. If I look at number 14, I have to find my own dots. So if I scan it, okay, bam and bam, right here is where it hits a corner. Then I continue on, here's where it hits a corner, here's where it hits a corner, here's where it hits a corner. So I can choose any one I want. I can do this one, which would be 5 over 2. If I do this one, it would be 10 over 4. If I did this one, it would be 15 over 6. And this one would be 20 over 8. And so then if I look at my division, if I did 5 divided by 2, it would be 2.5. If I did 10 over 4, it would also be 2.5, and it would be the same for the other two. So my constant of proportionality would be 2.5, and my equation would be y equals 2.5x, and that's it. Now, there is going to be some situations where, especially on this next test, where you have to be able to graph your own unit rate. So here's what I mean by that. It says 15 says, Troy burns 4 calories per minute while walking his dog. Notice on my graph, calories is over here and minutes is over here on the x-axis. So if it says 4 calories per minute, how many minutes is that? That's exactly 1 minute. So I have to figure out where 4 calories, right here, here's calories, meets 1 minute. And so where 4 calories meets 1 minute, I can put a dot. Well, how many calories do you think I would burn in 2 minutes? Well, if 4 calories is 1 minute, 2 minutes would be double that, so 8. Now, if you have 0 calories, that would also mean 0 minutes, so it goes to the origin. And so then you take your ID or ruler and you just draw a line. If I lost you, let me show you again. This one says an ATV travels 25 miles each hour. How many hours is that? That's 1 hour. So I'm assuming based off my numbers here, or it tells me here, where X is the number of hours, so this is my X-axis, so that's hours, and Y is my total miles, so my Y-axis is miles. I have to do 25 miles in 1 hour. So 25 miles 1 hour, put a dot. What do you think 2 hours would be? Well, double 25 would be 50. What do you think 3 hours would be? Well, triple 25 would be 75. 4 hours, 4 25s would be 100. 5 hours, 5 25s would be 125. And you see a pattern there? So my line would look like that. Not too bad. Let's step it up a level. If I say gas costs $2.50 per gallon, here's my cost, here's my gallon. Well, $2.50 per 1 gallon. If I look at 250, well, if I try to look for 250, it's not on the number line. That's because 250 would be halfway between 0 and 5. So 2.5 would be here for 1 hour, so it would kind of be between on the line right there. Well, if 250 is 1 gallon, I have to figure out how much 2 gallons would be. Well, think about what double 250 would be. Double 250 would be 5. And then if I did triple, that means 250 times 3, which would be 750. So 750 and 3. If I did 4 times 250, would be 10, so 10 and 4. If I did 250 times 5, would be 1250. If I did 250 times 6, it would be 15 and 6, and you see a pattern. So then that's what makes my straight line going through the origin. Let's do another one. This one says it takes her 5 minutes to travel 1 city block. Notice though, my city blocks are over here and my time is down here. So 5 minutes and 1 block would go there. Well, what's 5 times 2? 10. So it'll take 10 minutes to get 2 city blocks. 3 times 5 is 15, so 15 and 3 city blocks. 4 times 5 is 20, so 20 and 4. Then 5 times 5 is 25, 25 and 5. 6 times 5 is 30, and so on. So that's how you would build your own graph, which you'll need to know how to do on your test.